Hello children, how are you? I hope you all are doing well and studying well. So children, now we are going to talk about something, okay, by which, we do our work. What is that? Sometimes in order to do something, we have to put an extra effort. Now what is that extra effort? Oh yes, that can be force. And sometimes we need to add on to some more energy to it. So children, we are going to talk about force, work and energy in this chapter. So the chapter headlines is as clear that we are going to talk about force, we are going to talk about work and machine, how machines help us to do the work, and also about energy. Alright, so before we start, we need energy to give force and pull or push a thing. This is called work. Let us know about it in detail. So children, in order to push something or pull a thing, okay, we need an energy. And because of that energy, we can apply that force. And once we apply the force, okay, our work is done. Okay, so everything is interconnected. Alright, so experimental learning, look at the pictures and tick which action would need more physical energy. So, which is the action over here in the pictures for which you may need a little more physical energy. Okay. Now, let's talk about what is force. Force is the push or pull on an object that causes the object to change the direction or to change the shape. So, for example, okay, you've kept a table. Okay, you see that there is a table in front of you. Now, your mother says that get that small table or the stool which is there, I need to remove something from the kitchen. So, what are you doing? You are applying force, okay, and you are lifting that table and taking it to the kitchen. Okay, so that means you have applied some energy to it, okay, you have applied a force to it, you have pushed, either you push that object or you pull that object, okay, and then you see that the object's direction has been changed, okay, or sometimes even the shape changes. How? We'll see through the examples there. Now, in football, when you kick the ball, you are applying force with your feet, which causes the ball to move. So, this is a very simple and a very basic example that whenever you are playing football, you kick it, the ball's direction changes. It does not necessarily go in the straight direction. So, it can go in the right, it can go in the left, it can go in a circular motion, anyway, okay. So, that means the direction has changed. Similarly, you can change the size or shape of a rubber band by stretching it. So, if you have a rubber band in your hand and you apply a little force and you stretch it, okay, it will get pulled, it will get stretched out, and once you release that pressure, it will come back to its original position. That means the size and the shape has changed. However, when you release the force, it comes back to its original shape. Okay. So, force causes things to move, it causes things to stop, to change direction, size or shape. Alright. So, what are the different types of forces? So, in nature, there are different forms of forces. Okay. So, not necessarily that we have to apply the pressure every time, but nature also, in the nature itself, you know, it's a, as we all know, everything around us is science. Okay. So, nature also plays its own role. Okay. So, there are different forms of force which the nature applies. Okay. So, let's talk about the first one, which is a very common one and you must have heard about it, that is gravity. So, the force by which earth pulls objects towards itself is called gravity. That means when we are dropping something, it falls on the ground. That means it's coming towards the earth. Alright. So, the object gets pulled towards the earth. So, that is known as gravity. Okay. When we throw anything up in the air, it will always fall down, okay, or back on the ground. Has it ever happened that you've thrown the ball in the air and it has not come down? No, that is not possible. It will all eventually come back to the ground. So, this is because the earth has a force that pulls everything towards it. Okay, now this force is also known as the gravitational force, and Isaac Newton, he had first proposed the theory of gravity. So he was the one, okay, he was sitting under a tree and suddenly an apple falls down from the tree. That's when he realized that, there is something called a force of gravity. Okay, there is a gravitational force because the apple always falls down. It does not go up. Okay, that means the earth is attracting things towards it. Okay. Okay, so then now we are going to talk about the next one, okay, which is the buoyancy. Now, what is buoyancy? Now, this force, it pushes an object upwards. Now, in this force, you are pushing an object which upwards, okay. Ship floats on water due to this upward force exerted by water, okay. Now, this is known as buoyancy. Next is lift, okay. Why do aeroplanes not get pulled down to the ground by gravity? Okay. So, in buoyancy you see that there is a force which is exerted by water, and that is the reason why the ship is able to float on the water. However, when you look at the aeroplane in the sky, okay, although there is a force which is known as the gravitational force, but it does not get applied to the aeroplane. Now, why is that so? For air to hold a plane up, you need moving air, okay. So, for an object to fly, what do you require? You require moving air. The faster the air, the lower the pressure. The air that goes over the wings has to be faster than the air that goes under the wings. Okay, so whatever the air is there which goes over the wing, okay, it has to be faster than the one which is under the wing. Now, high pressure from underneath the wings pushes it down, pushes it upward, okay, and then keeps the plane up. Now, this is called lift. So, what happens is when there is air, okay, the faster the air moves, okay, the lower the pressure, okay. The air that goes over the wing, there is an air which flows over the wings, okay, it has to be faster than the one that goes under the wing. Okay. Now, high pressure from underneath will always push the wings, okay, upwards, okay, they will lift up. So, if you have ever sat in an aeroplane, you will see that in the wings you will see a certain type of plates, they move upwards because of the wind, okay, and this upward movement, okay, because of the high pressure, it makes the aeroplane stay stable in the air, okay, and does not get pulled towards the ground. Okay. Now, this is known as the lift. Next is friction. Okay. Now, when you rub something, what happens? You feel friction. So, now the force which stops or slows down, okay, a moving object, that is known as friction. When we apply brakes on a moving bicycle, okay, so you are riding a bicycle, you apply the brakes. When you apply the brakes on the bicycle, the brakes, they rub against the wheels, okay, and friction between the brakes and the wheels slows down the bicycle. So, as soon as you apply the brakes, okay, if you apply the brakes slowly, the bicycle will slow down. However, when you apply an urgent brake, you will see that immediately it stops. Okay. Now, to stop the bicycle, sometimes you have to place the foot on the ground as well. So, the friction between your foot and the ground, it makes the bicycle stop. So, there is a friction that gets applied between the foot and the ground by you, okay, and then the bicycle stops. Okay. That friction holds your foot to the ground, and that is the reason why wherever you are, the bicycle immediately stops. Similarly, a rolling ball, okay, will come to rest because of the force of friction between the ground and the ball. So, if you will see that there is a ball rolling, but after some time it just stops, okay, because the force of friction, okay, between the ground and the ball has made that ball stop after some time. Okay. The smoother the surface, the less friction there is. Okay. If there is a smoother surface, the friction is less. Okay. Now, let us see how do we do our work, okay, and what all things we require to do our work. Okay, so we are going to talk about work and machines. Work is done only when an object moves over a distance on applying force. So when you apply a force on an object, okay, it moves over a distance. If you move a pencil, okay, if you ride a bicycle and lift a heavy load, work is done. So if you are doing any type of work, what is a work? Anything that you makes an object to move, okay, so that is work. So even when you are talking, okay, your hands are moving, your mouth is moving, so something is moving, okay. So you are applying a little force to move an object, that's when your work is done. So in order to write, okay, you are moving a pencil. In order to ride a bicycle, you're pedaling the wheels, okay. So that means the work is done. But even after applying lots of force, okay, if you're not able to move an object, okay, no work is done. So even if you're applying a lot of force and that thing is not moving from its place, that means the work is incomplete, it is not done. So work done is equal to force applied multiplied by the distance travelled, okay. So anything we say that the work is done only when you apply the force and the object moves a distance. Clear? If it does not move, that means that the work is not done, okay. It means that you may need more force to do that work, okay. A boy is pushing the big box, okay. A man trying to move a rock. That means if it moves, work is done. If it does not, work is not done, okay. Now sometimes in order to make our work easier and faster, what do we use? We use machines, okay. So there are some simple machines that we use, okay. Machines are the equipments, okay, that make a difficult task easier, okay. So simple machines help us to do our work faster and do our work with less effort. So when we do something which is with the help of a machine, okay, work is done in a quicker manner. At the same time, okay, we don't have to apply a lot of pressure or a lot of force, okay, and the effort is less. So take an apple, try to cut it without a knife. It is very difficult. Can you just cut the apple into two without a knife? No, it becomes very difficult. Now use a knife to cut the apple. The knife made our work easy, and here knife is a simple machine. So when you cut the apple with the knife, it just slices open, okay. So it becomes easier with the help of a knife, which is a simple machine, okay. So some examples of simple machine are lever, pulley, wheel and axle, inclined plane, screw and wedge. So let's talk about lever first. Now a lever is a simple machine, okay. It helps to lift heavy or loads and to cut the things. So it is a machine, it will help us to lift heavier objects, okay, and also cut things. So scissors, bottle openers, they are examples of lever. A hammer, it is also a lever, okay, when it is used to pull out a nail from a piece of wood. So if there is a nail which is which is stuck in a piece of wood, you can apply some force with the help of a hammer, okay. You can hit it from the sides and slowly and gradually the nail comes out of the piece of wood, okay. So playing children on seesaw is also an example of lever, okay. Next is wheel and axle. So the wheel and axle, it is an arrangement that helps to move things from one place to another easily. So they can, with the help of a wheel, okay, you can move the objects. So imagine, okay, for example, your mother goes to the market to buy vegetables, okay. Now she carries some bags with her and she takes it to the market. So when she's bought everything and she's coming back home, the weight is more, okay. However, in place of only the bags, she carries a trolley. So when she carries a trolley with her, what happens is that it becomes easier for her to lift the vegetables or drag the vegetables on the trolley, okay. It is very easier to use, okay, and it has applied less effort also, okay. It has made her work easy also. So, she is able to carry the load easily. Clear? So, force applied on one device rotates the other, and the wheel and axle arrangement works. Okay? So, steering wheel, doorknob, gears in clock, and watches and bicycle, they are examples of wheel and axle. Next is the inclined plane. So, sometimes you must have seen near the hospitals and all those places, or even in the malls and all, you see that there is an area which has a ramp like thing. Okay. So, it is like, you know, slanting type of a thing. So, that is known as an inclined plane. So, now what happens is an inclined plane is actually a sloping surface, okay, which is used to push or pull heavy objects. So, you will see in the hospitals and all, when the patients are coming, they will generally make the patient sit in a wheelchair, okay, and pull the patient up the ramp, okay, and take them to the hospital, inside the hospital, or bring them outside the hospital on a ramp. Now, this ramp is an inclined plane. It's a sloping surface. Okay. A strong and smooth board placed at an angle can be used as an inclined plane. So, you must have seen heavy cartons being loaded onto a truck by pushing the carton up by an inclined board. So, now this inclined board is kept in between the truck and the ground, okay, and then those cartons are pulled inside the truck using a chain or a rope, okay, and the boxes get loaded onto the truck easily, or the cartons get loaded onto the truck easily rather than lifting and keeping them. Okay. Wedge. Now, wedge is also a simple machine used to push two objects apart. Okay. So, in order to push two objects apart, okay, separate them, you use a wedge. So, it is made up of two inclined planes. These planes meet and form a sharp edge. This edge can split things apart. Now, this edge which is there, okay, these planes, they have two sharp edges and they can be split apart. Example is, we use an axe, okay, in order to cut wood. So, in order to split the wood into two pieces, we use an axe and we cut it into two parts. Okay. Other examples are knives, forks, nails, etc. Okay. Now, this thing that I am going to talk about next is a very common thing, and I am sure that all of you must have definitely seen it at home. Yes, I am going to talk about screw. So, a screw, it has ridges, okay. You will see that there are ridges on that, okay. So, and it is not smooth like a nail. So, there are two things, one is a nail and the other one is a screw. So, screw, you will see that there are ridges inside on the bottom part of the screw. So, screws, they are used to lower and raise things, okay. So, in order to lower something or fix something or to remove something, you use a screw. So, they are also used to hold objects together. Jar lids, bottle caps, light bulbs, they are all examples of screw. Next is pulley. Now, pulley is generally, you must have seen it on a well, okay. So, a pulley is made from a wheel, there is a wheel and there is a rope, okay. So, it makes the work of moving heavy loads a lot easier. So, with the help of a pulley, it is lots easier to lift heavy loads, okay, with the wheel which is attached and the rope, okay. So, cranes, they use pulley to lift heavy loads, okay. Pulley is also used to hoist flags, okay. Now, in order to do all this work, okay, and in order to make the machines work also, what do we need? In order to make the machines work, in order to do the work, okay, we need energy. So, energy, it is the capacity of a body to do work. So, for any body to perform any kind of work, okay, what do you need? You need energy. So, when you apply force on an object, okay, your body, it uses energy. So, whenever you are pushing something, you are using a lot of energy, okay, you are applying a lot of force. For example, in order to move a table, okay, you apply force, and to do so, your body uses energy. So, your body, it produces energy through what? Okay, it gets the energy from where? We get our energy from the food we eat, Okay, and that is the reason why we keep telling you, eat good food, eat a balanced diet, so that you get good energy to do your work. Okay, so a moving car, it uses energy from the fuel it burns. Whenever force is applied, energy is used. Now, what are the sources of energy? Like, yes, food is one of the sources of energy, fuel is one of the sources of energy. So, what are the other sources of energy? We are going to talk about it in detail now. So, energy is what makes everything in the world happen. Okay, so everything that happens is because of the energy that is applied on it. Okay, so energy is defined as a capacity of a body to do work. So whatever work a body can do, it's because of the energy that it has. Okay, so even when I'm talking to you, I'm using a lot of energy. So we need energy to use force. We cannot always see energy. So there are energy is something that we cannot always see. Okay, so but we can see the effects of it. Okay, like the wind energy. Okay, so because of the wind energy, you will see that the windmills are moving, and because of that water is generated. Then there is hydro energy also, because of which dams, which is near the dams, and the water is generated. Okay, so all these things are what? Okay, energy. So without energy, nothing could live or nothing could grow also. So there would be no heat. Okay, as I said, okay, we get the solar energy from sun. Okay, so when we put up the solar panels, it attracts the sun's energy, and we are able to generate heat and electricity through that also. Apart from that, windmills, they help us to get the electrical energy. Okay, so hydro energy is there is sound energy, there is movement energy. So these are different forms of energy that are used to do work. All right, so now let's do a quick recap of the chapter. A pull or a push acting on an object, it is known as force. Some of the forces in nature are gravity, friction, buoyancy, etc. Machines, they make our work easier, and the ability to do work, it is known as energy. Energy, it exists in different forms, like the heat energy is there, light energy, sound energy, electrical energy, mechanical energy, chemical energy. So many different forms of energy exist in the world. Okay, now sun, wind and water, they are the main sources of energy. All right, so I hope children, now you know about this chapter, which is based on force, work and energy, and I'm sure that you are all going to read this chapter all over again, and then get on to the back exercises quickly. All right children, get going.